Hello, my name is Noah Johnson. I'm presenting a demo of my ThirdEye project that I'm doing in conjunction with the Smart Networking and Computing Lab at the University of Rhode Island. So what we aim to fix in this project is the fact that drivers are generally pretty distracted nowadays. There are a number of fatal crashes every year related to distracted driving in the part of both drivers and passengers. So now why does this occur? This can happen because of anything from poor vigilance to lack of sleep to music or conversations with passengers. So it's fair to say that there are a number of things that can cause drivers to get distracted. Okay, so the problem here is what are we going to do to promote safer driving without contributing to the problem more? And the solution that I propose, or that we propose rather, is to use augmented reality and object detection to detect hazards that drivers may miss. So let's go over what augmented reality is real quick to just give everyone a bit of a background. So augmented reality is an application of cutting-edge machine learning and rendering technology that samples real-time data of the environment that it is in and uses this to augment how we interpret the world around us. So everything from Snapchat filters to live machine translation of text on a sign, let's just say. That those are both applications of AR, to give you a few examples. So it's fair to say that this is an extremely promising field with far-reaching implications within the next couple of years. So let's talk about what ThirdEye actually is. So the ideal implementation of the ThirdEye application would be on a phone that was mounted as a dash cam in a car, and it would use real-time image data from the phone's camera to detect hazards in the road, such as pedestrians or upcoming stop signs, or debris in general, and use that to alert the user with some sort of audio alert or something of that nature. So what's the problem with this implementation? The naive implementation would be to just do all of this work on the phone. However, obviously mobile phones are not nearly powerful enough to perform this kind of work at anywhere near a real-time speed. So that's not a possible implementation. We can rule that one out. The next naive implementation would be to do all of the work on a remote server and just offload all of the work from the phone to some powerful server. Now, while this is better, we then run into the problem of extremely high communication delay between the phone and the server. So that creates problems. So instead, what we're looking into doing is executing part of the work on the phone and part of the work on the server. Now, there are a lot of different ways to do this, so there has to be an optimal way to do this. We are looking to optimize this. And the central research goal that we have here is, well, it's one of two research goals. The first is to perform detection not on the entire stream of video data, meaning every single frame that the camera sees, but only on the important ones, the ones that are significantly different, using a naive frame differencing algorithm that we are developing right now. The second research goal is to create a framework that will determine the optimal partition point within a machine learning graph to execute on the phone and the server. And by doing this, we'll be able to hopefully approach real-time execution. So now let's see a demo of our application as implemented. Now, as you can see, the detection as done on the phone is fairly slow. As I said, we are still developing this, so the algorithms are not completely implemented yet. But once implemented, we believe that these will be a lot faster. But we can see that it is able to perform object recognition and recognize road signs. And ideally, we would be doing this in the real world, mounted on a car hood or on the dashboard of a car. So, once again, my name is Noah Johnson. This has been a demonstration of the ThirdEye project. Thank you.